Continuing with question number 5. A hemispherical depression is cut out from one face of a cubical wooden block. Alright, so you can see that this is a cubical wooden block. So they say that they are taking a depression out, right? So remember, they made the depression like this, right, in the shape of a hemisphere, and they took it out here. Alright, but remember that even when I take it out here, the depression will be there, right? There will be a hemisphere here inside. Alright, okay. Blocks such that the diameter L of the hemisphere is equal to the area of the cube. So you can see that the diameter here I've marked it with the red, right? So this diameter is equal to area of the cube, means the length, okay, this. So we know that in a cube, if we know one side, all the others are same. That's why you can see that this is L, this is also L, L, L. Alright, so now what are they asking us to find? Determine the surface area of the remaining solid, right? So how do you find this? First, we'll take the total surface area of the cube, okay, the whole thing, the whole cube, right? Up, down, left, right, front and back. Total surface area of the cube plus curved surface area of the hemisphere, because remember here there's a hole now, right? The hole is in the shape of a hemisphere, right? And then once again we have to subtract it with the base area of the hemisphere, because see, when I took the total surface area of the hemisphere, right, I took everything here, clear. But what happens here is that I only need this area. This is a surface area, right? That's why I have to subtract this area of the circle. Alright, area of the circle or base area of the hemisphere. If I subtract it, then I'll get this region here. Okay, so that is what we'll be doing. So once again, they have given us the diameter of the hemisphere, which is also equal to area of the cube is L. So if the diameter is L, then obviously radius will be L by 2, right? Now we're going to find a surface area of the remaining solid. So like I said, total surface area of the cube plus curved surface area of the hemisphere minus base area of the hemisphere, which is a circle. Alright, so the total surface area of a cube, what is the formula? It's supposed to be 6a square, right? But here we got the h to be equal to L, right? That's why in place of a we're taking it to be L. Okay, then curved surface of the hemisphere, the formula is twice pi r square, and the base area of the hemisphere, you can see here, this is a circle, right? So we're going to put the area of the circle formula pi r square. So now you can see 2 pi r square minus pi r square, so 2 minus 1, I'll be just left with pi r square. So pi, you just leave it as it is. Radius is what? Radius is L by 2, right? So I've written L by 2, L by 2. If I multiply it, now I'll simply be having 4, right? So pi L squared divided by 4. If I try to find LCM, remember here LCM denominator is 1, right? So if I find the LCM of 1 and 4, obviously LCM will be 4. So I've written here. Then write down the numerator, 6L squared written. 1 how many times are 4? 1 4 is a 4. Write down the numerator, pi L squared, right? 4 how many times are 1? 4 1 is a 1. So I did not write here, but if you write, you write it down, okay? So once we have put that written it down, 6 4s are, I'm going to have 24L squared, and then plus pi L square, right? So from here I'm going to take out 1 by 4 out here, and you can see that L square is common, right? So I've taken it out. Then what will be left inside here? 24 plus pi, which will be the surface area of the remaining solid.